Hello. So now we're going to do this problem. It deals with Claire's enterprises. And it's going to be a very exciting problem, okay? So let's do it together. Let's get started. So let's read it together first. The weights of packages in Claire's enterprises follow a normal distribution with an average weight of 5 kilograms and a standard deviation of 10 grams. What is the probability that a randomly selected package weighs between 4970 and 5010 grams? Okay. The first thing you have to realize, of course, is that average and mean mean the same thing, and so here the average is 5 kilograms. And in this case, you can see that these numbers are in grams. We know that 5 kilograms corresponds to 5,000 grams, so that's going to be an important little fact that we're going to have to, that we had to understand first before we can do anything else. Now I think you guys already know what I'm going to do. I'm going to instantly write the answer down. No, I'm just kidding. We're going to have to draw the picture, okay? So let me draw that picture here like this, okay? Okay. Man, this drawing is so bad. I don't know why my drawings just always keep getting worse and worse. It looks like a shark fin and not a normal distribution, but we're going to pretend it's perfectly symmetric, okay? And if anyone says otherwise, like, I'm going to be deeply hurt inside and I don't know what I'm going to do to, like, survive outside of that pain, okay? As we know, the mean goes right in the middle, 5,000, 5 kilograms. And we know that the standard deviation here is 10 grams. So it's gonna, so if I take 5,000 and I take away 10, that corresponds to 4,090. If I take away 10 again, 4,990, right? Yes. Yes. If I take away 10 again, I get 4,980. If I take away 10 again, I get 4,970. Now I'm going to add the standard deviation to the to the mean. Okay? So that's going to be 5,010, right? Because I'm adding 10 grams. I'm going to add 10 grams again, 5,020. And then finally, I'm going to add again 5,030. You can see here that this is the mean. This is the mean plus one standard deviation. Okay? This is the mean. Not plus. In this case, it's minus because I'm going to the left. Here it's the mean minus 2 sigma, minus 2 standard deviation, and the mean minus 3 standard deviations. And of course, likewise on the other side, right? Here, this is going to be the mean plus 1 sigma. This is going to be the mean plus 2 sigma, and this is going to be the mean plus 3 sigma. Okay? And now the question is, what is the probability that a randomly selected package will have a weight between 4970 and 5010 grams? In other words, if I look at this picture and I draw it, I want to go from here all the way to here. So let me shade that in. We want this area. But we have a problem. If it had been just this, if it had been from 4990 to 5010, then by the empirical rule, I'm sure all of you are already thinking, well, David, that would be exactly 68%, right? If it was just this part here, but it's not. Or if it was this, right? It would be 95%. But here we have a different situation. My boundary over here is mu minus 3 standard deviations, the mean minus 3 standard deviations, all the way to the mean plus 1 standard deviation. Okay? So how do we do this? Here's how we're going to do it. Okay? Let me draw a schematic of what I'm about to do. So first of all, what we can do is we can think about the normal curve and break it up into regions, okay? So the region from mu minus sigma to mu plus sigma, okay, that is part of the solution of our problem, right? Because it does go up to mu plus sigma, and I do have the mu minus sigma. So I'm going to call this region R1, okay? But then I also have this region from mu minus sigma to mu minus 3 sigma, right? I'm going to call this region region 2, okay? Now, fortunately, we already know that region 1 has area 0.68. Why? Because of the empirical rule. If we go from the mean of any normal random variable minus 1 standard deviation all the way to the mean of that normal random variable plus 1 standard deviation, the area in between those boundaries is 0.68. So I'm going to write that down here. Okay? So now the question becomes, how do I get the area of region 2? Okay? And here's how we're going to do it. Let me draw it here. The region I'm interested in here. Oh man, by the way, I know it touches here on my drawing, but it doesn't. But like okay, I'm going to delete that so you don't see that connection because they don't touch. Remember, okay, so this is a little side point, but the graph of the normal distribution never touches or crosses the x-axis. It just gets closer and closer. Okay? Okay. Okay, so what I want you to observe is this. Okay. Let me see here. This is mu minus 3 sigma, and this is mu minus sigma. Okay. 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 I want this region. That's my region 2 area. Now, what I'm going to do to get this area is the following. I'm going to consider mu. Okay. Let me use a different color here so you can see what I'm about to do. Look at this. I have now shaded in over here in blue the region from mu plus sigma to mu plus 3 sigma, which by symmetry must have the same area as this. Okay? I think you guys can see what I'm about to do here, right? So watch this. What I'm about to do, okay, is I know that the area of this whole region from here all the way to here has to be 99.7% of observations, or in a probability term, 0.997, right? So if I were to take from here 0.99 all the way to here, right? I'm then going to subtract from here to here, which is 0.68, right? So if I do that subtraction, let me do that here, okay? 0.997 minus 0.68, I get 0.317. So region 2 here plus this reflection of region 2 here, when you add them together, is 0.317. And how did I get that? I got that by subtracting 0.997 we can see that here. 7 minus 0 is 7, 9 minus 8 is 1, 9 minus 3, and 9 minus 6 is 3, and then I bring down the decimal point. Right? So notice what I did here. I attached a piece that wasn't there before, right? Just by reflecting it on the normal curve like this, and I saw that gave me the boundary lines for the mean minus 3 standard deviations all the way to mean plus 3 standard deviations. And I know the area underneath the curve for that because of the empirical rule, 0.997, right? I then noticed that the interior boundary was mu minus sigma all the way to mu plus sigma, which from the empirical rule tells me that the area in here would be 0.68. So by subtracting this 0.68 area from the 0.997 area here, I get left with the area of this plus the area of this. But I don't want the blue part, right? But here's where the symmetry plays a role. This piece must have the same area as this piece. So I can divide this value by 2. Okay, and why is that the case? That's because it's symmetric, okay? Okay, so now let's divide it by 2. So two goes into 3 once. 1 times 2 is 2. 3 minus 2 is 1. I bring down this 1. 2 goes into 11 5 times. 5 times 2 is 10. 11 minus 10 is 1. I bring down the 7. That's a 7. 2 goes into 17 8 times. 8 times 2 is 16. Okay. 17 minus 16, that's 1. Okay, that's, I kind of went off the paper there, so let me do that over here. Okay. So. The question is 2 goes into 3 1 7. 2 goes into 3 once. 1 times 2 is 2. 3 minus 2 is 1. I bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10. 11 minus 10 is 1. I bring down the 7. 2 goes into 17 8 times. 8 times 2 is 16. And then, let me see here. And then here, I subtract them, I get 1. But because the decimal place is here, I can already add another 0. 2 goes into 10 5 times. Right? So 0.1585. Okay? That is the area of region 2. So region 1 is equal to 0.68. Region 2, which is the part from mu minus 3 sigma to mu minus sigma, that is 0.1585. And when I add those together, I'll get the area from mu minus 3 sigma to mu plus sigma. Okay, so let's add those together. Let me see here. Oh my God. Running out of room here. Now, of course, you guys have a calculator, so you can easily do this, but like, you know. So, of course, 0 plus 5 is 5. 0 plus 8 is 8. 8 plus 5 is 13. 1 plus 6 is 7. Plus 1 is 8. And then I bring down my decimal point. And so we can finally say that the probability that the package will weigh between 4970 and 5010 grams will be 0.8385. Okay? Yes. I hope you've enjoyed this problem, and of course, as you can tell from this problem, the reason I wanted to show it to you is that even though the empirical rule, from when we first saw it, we thought we're going to be using symmetric regions that are the same number of sigma from the middle, but we saw that that's not necessary. It can be like a kind of like a asymmetric region whose boundaries lie on the multiples of sigma from the mean, and we can exploit the empirical rule on the pieces to find the area that we want. Okay, so the empirical rule can be applied to certain problems where it might not immediately be apparent that it could be applied to. And of course, on another note, again, we see the importance of drawing pictures and trying to see what those pictures tell us about the problem. And well, I hope you guys have enjoyed that, and let's move on to another problem. Thank you.